This is the second big picture general overview video on graphing sinusoids. This is going to be a little longer and not quite as detailed as the individual homework problems. But I want to give you some basics that will be useful for you as you go into homework 8.2, graphing sinusoids 2. So you'll recognize this from the previous homework problems. This is not something where I'm going to go fill in the XY coordinates. I'm showing you this picture because there's something interesting about it, which we've mentioned in class normally when we are in school. But since we're in virtual, we're doing our best now. On the top, we have a sine function, right? We recognize that as sine x. On the bottom, we have cosine x. But you might notice that this bottom curve, it could be argued, is kind of a little bit of a sine function, right? Sine and cosine are similar to each other. Now just look where I'm going to start my sine curve. Right there. Starts at the middle, goes up, comes back down, goes back up. That's a sine curve, that purple thing I just drew right there. Well, it's not exactly a sine curve in the same sense as the one on top because it starts at a different place. And that idea of moving your curve left or right on the x-axis is what is called our phase shift. Okay, I mentioned that previously. It's time to get into phase shifts. So all phase shift is a horizontal shift. Okay, that's it. It is no more complicated than that. Sometimes it looks complicated, but when you just remember what this is, it's a shift left or right along the x-axis. Phase shift is very easy to deal with. Now I want to go through some conceptual examples before we get into the equation stuff. I'm going to tell you that each one of these curves can be expressed as some kind of a sine curve. Well, some kind of a sine curve with a phase shift. What the phase shift is, remember how I pointed to it right over here? It's this h term. Wherever you see the sine wave starting, that's where I want you to label the phase shift. Okay, so in this first one, phase shift is right over here. So it starts there. That means this curve is sine of x minus, what is that thing? That is negative pi over 2. Okay? Or in other words, sine of x plus pi over 2. All right? So when you have a negative phase shift, it's actually going to show up as a positive in the parentheses because the horizontal shifts do that weird flip thing where they flip the sign. How about this next one? Where's the starting point? You can look around. You could say there's a starting point right here. You could also say there's a starting point right here. I'm not going to mark one of these wrong because you picked a different starting point when there's two available on the screen. Pick whichever one you want, which is the actual starting point. This would be called sine of x, and there's no phase shift. Or, if you wanted, you could say there is a phase shift. It's at 2 pi. Sinusoids have this repetitive pattern to them. So if you tell me there's a phase shift, which is 2 pi, I'd say that's equivalent to a phase shift of 4 pi, 6 pi, 0 pi, right? They're all equivalent sine functions. How about this next one? Where's the starting point here? Well, I'm seeing it right here. So I would say this is sine of x minus pi over 2. Okay, getting the idea? Now, you could probably do the same thing again for this curve, right? You would say, oh, there's my phase shift of pi, and that would be fine. But I'm just going to stir the pot a little bit here and say, pretend it's a cosine function. Can you write it as a cosine curve? Well, where's the starting point of the parent cosine curve? I would say it's the top. Cosines start at the top at a high amplitude value, and then they come down from that. So you could say it's right here. You could also say it's back here. Either one of them would work. You could say cosine of x plus pi over 2 is your function, or you could say cosine of x minus 3 pi over 2. Those are both correct ways to describe this using a cosine curve. So you see, you can use sines or cosines to describe sinusoidal waves. It just depends what your reference is, what your phase shift is that you're talking about. Okay, so now let's talk about the equations, how we describe these things. Previously, I wrote an equation like this, and let's see, it went y equals a, that's the amplitude, times sine, so it's a times sine of b, x minus h is the phase shift, plus k. This is called your standard form, and any sine or cosine curve can be written this way. If it's cosine, you just have cos instead of sine. And what I want to know is take a look at these problems below in this question and give me the equation of the midline, the amplitude, yada, yada, yada for these things. I'm only going to do 2 of them because I think we'll get the idea. Let's pick on this guy first. So you'll notice it's not in standard form, right? The k variable is actually out in front. Well, that's fine. It doesn't actually matter because a plus b equals b plus a, right? So don't get distracted by that. It is still k. It is still the midline. So we would say the midline is -4. In fact, I just made an error there. Look at this. This is the equation of the midline. Okay, watch out. So the answer here is actually y equals -4. It's a horizontal line. It's like a horizontal asymptote. It's not an asymptote. It's a horizontal line. Y equals -4. And the amplitude for this one is just the multiplier, the vertical scaling in front of the cosine. So that's 4. Let's see what we got here. Period. Remember how we do period? We say period equals 2 pi over b. And in this example that we're doing, that is 2 pi divided by 1/3, which keep flip change says that's just 2 pi times 3 over 1, or 6 pi. Okay, so the period of this curve is 6 pi. It's going to take a distance of 6 pi before it repeats one cycle. And now we get to the phase shift, this new thing. Well, if you remember how this is written, we have this minus h here. So you're looking for a plus or minus after the x, and you have to flip that sign. Okay, so the phase shift on this guy will be negative pi over 2, because we flipped that sign from a positive to a negative. Okay, so let's try another one. And I'll call it quits here. I like this one right here, this guy, because it looks confusing, but it's really not. So I'm going to rewrite that. Because it doesn't look like my standard form, I'm going to rewrite it first, and I think that'll make it easier for us to figure out what's going on here. I'm going to say, let's factor out 5/6. And the reason I chose 5/6 as my GCF is because it's in front of x. I want x by itself. See, in standard form, x is just by itself right there. So don't tolerate 2x, 3x, whatever. Factor something out, and then you'll see what b is very clearly. Now, you have to be careful to factor the 5/6 out of -5 pi over 24. That might give you a little bit of concern, but it's really not that bad. You just take -5 pi over 24 and divide it by the GCF. So divide by 5/6. And remember what divide by means when you're dealing with fractions anyway. Keep flip change. What that really means is times 6 over 5. So the 5's cancel out. The 24 cancels out with the 6, becomes a 4 on bottom, just a 1 on top. So what do we have? It's just negative pi and 4 on bottom, I think. Yeah, so we have, instead of -5 pi over 24, we have minus pi over 4 inside the parentheses. And don't forget, we still have what looks like a midline, a vertical shift outside the parentheses there. So plus, oh, I wrote plus k, but that's in the equation we were given, that's a plus 4. Okay, so now we just put in our terms. This will be, the equation of the midline is y equals 4. It's the amount we added, our vertical shift. Amplitude is 2. Don't put -2. Remember, negative signs are not amplitude. Amplitude is always an absolute value. It's like if you have a weatherman and he says, we've got a storm surge of 10 feet, you don't have negative 10-foot waves, right? You have 10-foot waves. Even if they're going up 10 feet and down 10 feet, you always say 10 feet. Period on this one, looks complicated. It's going to be 2 pi divided by b, which is 5/6. Okay, so I do a little math in my head here. That's going to be 12 pi over 5. That's your period. If these pi's look weird to you, just remember pi is a number. It's 3.14, blah, blah, blah. So it is a distance. It's just got a crazy decimal on it. And then phase shift here, I flip the sign on that negative pi over 4. Phase shift is pi over 4. Okay? So, let's see what's next. I think this will be where we end it. I want to look at this graph and come up with some attributes about it, its key features. And I'd suggest pausing the video. We've been through enough of this now, but by now you should be able to do this on your own. But if you're stuck on a few of these points, well, unpause it and let's go through it together. Okay? Here's the midline. It's the middle line that cuts right through the function. And once we see where that is, we know what the amplitude is, right? It's however high it takes to get to our top point. And I count 1, 2, 3 units up, okay? So that's an amplitude of 3. And equation of the midline, we already said that, is y equals 4 because it's literally at y equals 4. Period of this thing. Well, now we're getting a little more not obvious. We have to do some math to figure out the period. And what I'm going to do is I'm going to point out this dotted red box that encircles the parent function. Okay, I should have said in boxes the parent, whatever. It starts at pi over 2. Okay, right here. That's the left side of this box. And it finishes at 9 pi over 2. And you see there's one complete cycle of the sine wave in there. So that's the period. Period equals 9 pi over 2, the right edge of the box, minus pi over 2, the left edge of the box. This is going to be our distance. You measure this the same exact way you would measure things with a ruler, right? If you have a ruler and you started at the 1 foot mark and you measured out to 8 feet, well, whatever you measured was 7 feet long. Okay, it works the same way with pi's and radians and things. So the period is 8 pi over 2. You can simplify that if you want, right? That's just equal to 4 pi. And the 4 pi there equals 2 pi over b. So now I'm going to do a little bit of algebra here. I'll multiply both sides by b, okay? And we get 4 pi b equals 2 pi. Well, now you can divide each side by 2 pi, okay? And what do we get? We get 2b equals 1. Okay, not quite good enough. Let's divide each side by 2. So b equals 1/2. Great, so the b value equals 1/2. And period, we already found that out earlier. That is 4 pi, but if you said 8 pi over 2, that is fine. Phase shift is actually one of the easier things to figure out. You just look where it begins. It's the starting point of your parent function. So that is a phase shift of pi over 2. And now comes the point of all this. I want an equation which describes all of these parameters. So if we look at our standard form, y equals, what was it? A times sine of bx minus the phase shift plus the midline. We just pop those in here. So this becomes y equals 3 sine of, the b value is 1/2. 1/2 times x minus, the phase shift is pi over 2 plus 4. So take a look at those components, see if those make sense to you. Pay a special attention to the phase shift and the sign, the plus or minus sign of the phase shift. And you should have it. Now, if you want a little extension of this, try making it for a cosine. Remember, you can write any function as a cosine. Okay, pause the video there. See if you can figure that out. I want cosine of something. Okay? All right. I'll finish this one up, and then we'll call it a good. So you'll notice the amplitude has not changed. The midline has not changed. The period has not changed, which means b is the same. So the only thing that changed is the phase shift. Remember, cosines and sines are the same as each other. They just shift left and right. So where's the phase shift of a cosine function? If you look at the picture, well, right there. That's the starting point. Where the amplitude is highest, that's the start of a cosine function. So this is minus 3 pi over 2.